Hello everyone, in this video I'm going to discuss the example for differentiation, focus on the implicit differentiation and also the parametric differentiation. So kindly focus on the question. If y multiplied with the exponent negative 2x equals to cos 3x, find the value of the constant p and q for which the situation is given. So in here, my suggestion is to rearrange the situation. Notice that exponent negative 2x, if you try to imagine, we have y over the exponent 2x. So y, which is equals to exponent 2x cos 3x. So from here, the implicit, and we already modified it, become explicit. Make use of the product rule. So we have dy dx, which is equals to cos 3x bracket, we have 2 exponent 2x. Plus, we have exponent 2x, differentiate the cos, and we have negative 3 sine 3x. Rewrite the situation and make use of these parts. So dy dx, where we have the situation 2y minus 3 exponent 2x sine 3x. Continue. Differentiate for the second time. So we will have second derivative. If we differentiate 2y, we will have 2 dy dx. Minus the 3 bracket, we have sine 3x. Differentiate the exponent and we will have 2 exponent 2x. Plus exponent 2x, if we differentiate the sine 3x, and we will have 3 cos 3x. Rewrite the situation. So the dy dx for the first derivative. So if we focus on this part, and we will see the 3 exponent 2x sine 3x. If we rearrange, actually we will have 2y minus the y prime. Continue. For the second derivative, we have 2 dy dx. Minus, we have the 6 exponent 2x sine 3x. Minus the 9, then we have exponent 2x cos 3x. So if you notice the highlight part, so it will become y. So rewrite the situation. So we have 2y prime minus, if you focus on this part, so actually we have the negative 2 bracket. So we have 2y minus the y prime. Minus, if we focus on this part, actually we have 9y. So try to rearrange the situation based on this part. So we already have the second derivative. Then continue. We have the situation 2y prime minus, we have the 4y minus the 9y plus with the 2y prime. So based on this part, we already have 4y prime. And then based on this part, we have negative 13. So for the second derivative, so if we rearrange, we will have negative 4 dy dx. And then plus 13y equals to 0. So kindly compare this part. So the p, which is equals to negative 4, and the q, which is equals to 13. Next, kindly refers to b. So given the situation, we have x. If we differentiate, we will have dx dt, where we have exponent t. If we differentiate t, we will have 1. Next, differentiate the exponent negative t, we will have negative exponent negative t. So that is the dx dt. For the dy dt, so we will have 1 over 4 bracket. So if we differentiate, and we will have 2 bracket, so exponent t minus exponent negative t bracket. Differentiate the internal function, so we will have exponent t plus the exponent negative t. So that is the dy dt. Try to simplify the situation. So dy dt, where we have 1 over 2 bracket, we have the exponent t minus exponent negative t, multiply with the exponent t plus with the exponent negative t. Continue. Refers to the number 1. They ask you to show that the dx dt squared plus with the dy dt squared, where we have 4y, multiply with the 1 plus with the x squared. So kindly substitute the situation. We have the dx dt bracket squared, plus we have the dy dt bracket squared. So if we substitute the situation, so we will have et minus e negative t bracket square plus, continue for another part. So we will have 1 over 4 bracket exponent t minus exponent negative t bracket square exponent t plus with the exponent negative t bracket square. So based on this part, we can factor out the situation given. So notice that we have the common terms, and we have here will be the common terms. So if we factor out, we have exponent t minus exponent negative t bracket square. Bracket, we have 1 plus, we have the exponent t plus with the exponent negative t bracket square over the 4. Try to refer to the situation given. Notice that in here, actually we have the same terms. So where we have, it is equals to 4y. Bracket, we have 1 plus. Notice that in here, we have this kind of thing, x squared. So from here, we can substitute the x squared over the 4. So rewrite the situation, dx dt bracket square plus with the dy dt bracket square, where we have 4y multiplied with the 1 plus x squared over 4. So we already shown the situation given. Next, kindly focus on the number 2. Find the dy dx when t equals to 1 over 2. First of all, find the dy dx, where we have dy dt multiplied with dt dx. So we have 1 over 2 bracket exponent t minus exponent negative t bracket exponent t plus with the exponent negative t. Multiply, we have to flip the situation. So here we will have exponent t minus exponent negative t. So if we simplify, we have exponent t plus with the exponent negative t over the 2, where we have the dy dx. So in here, let's say t equals to ln 2. So we have e ln 2 plus e negative ln 2 over the 2. So we have 2 plus we have 1 over 2 over the 2. So the dy dx, where we have 5 over the 2 over the 2. So based on the situation given, we have 5 over 4 is the dy dx when t equals to ln 2.
Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.